Okay, so then going to number 2, I should say to the next graph. So this is a distance time graph. Its units are meters per second. Where's where? That's it. MS, meters per second. Okay, here's the next graph. All right, and again, this is a review. You should see this and say, I know exactly what's that doing. All right. So what this is doing is this again is moving away from the origin. And if you take your pencil and trace it, you'd find that your pencil lays down, so it's slowing down. Again, the first thing from now on, the first thing you need to do, because you will be seeing 2 different types of graphs on your test, is you need to go straight to the units and see what we're dealing with. In this case, again, we're dealing with a distance time graph. Okay? You should recognize by this point that this graph represents an object going away from the origin. And you should also recognize that it is slowing down. Okay, so it's going away from the origin and it is slowing down. All right, again, distance time, so this is meters per second. Okay, here's the next graph. Everybody go ahead and draw that graph. And again, the first thing I do is I need to know what type of graph I'm dealing with. So I come up here and I say that yes, I am dealing with a distance time graph. Okay, distance time graphs again are the ones y'all should be very familiar with. So, what type of motion is this describing? Well, it's moving at a constant speed away from the origin. Okay? Constant speed away from the origin. Okay, moving on to the next one. Okay, last one. Again, first thing I do is I go look at my unit and make sure I know what type of graph I'm looking at. This is going to be the one thing that gets many of y'all on the test, is you're going to just assume that they're all the same and you're just going to start answering questions. No, first always go and look at the unit. In this case, the unit is distance. And what you should know about this graph is this object moving? No. For example, if this is 5 meters, it's doing what? It's sitting at 5 meters, not moving. Okay, so this graph is not moving. All right. So it's not moving, it's sitting 5 meters from the origin, for example. All right. So, again, please do not get confused. You know what you know, but let's move on and talk about a different type of graph. And that's going to be a speed time graph. Okay, so here we have a speed time graph. First, let's talk about the unit. Speed is measured in meters per second. So in other words, when they say speed, what they mean is meters per second. And time, again, is in seconds. Okay, so meters per second and second. In other words, if we go back to the distance time graph, that was meters per second, which is speed. Here we have meters per second, second. So in other words, it looks like this. Meters per second. second squared. Whenever you see this right here, what you are looking at, meters per second squared, is an acceleration graph. Okay, so now we are looking at an acceleration graph, and how do I know that? Well, meters per second is the unit for acceleration. So in other words, I'm going to erase this here in a second. In other words, is that object speeding up, slowing down, or traveling at a constant speed? Okay, we'll look at it. That's speed, right? So let's think about it. If this is 0 meters per second, let's talk about miles per hour just to eliminate any confusion. Let me erase some of the stuff so I can get rid of my clutter. So let's talk about it as far as miles per hour. That's 0 miles per hour. This would be 5 miles per hour, 10 miles per hour, 15 miles per hour. So what do you think now, Shiloh? Same speed or increasing speed? So these are 0, 5, 10, 15 miles per hour. I'm sorry, same speed? No, it's increasing. Okay, this is a increasing speed. So what I want y'all to do, so what's going on with this speed time graph is this represents a increasing speed. In other words, it is accelerating. It's getting faster and faster and faster. Okay? So what I would like for y'all to do now is go ahead and draw an acceleration graph of a speed time graph. What would that look like as a graph? Distance time, I'm sorry. So this is a speed time graph. What I would like for you to do is draw the corresponding distance time graph, which is the one y'all are familiar with. Okay, so here, let's go ahead and draw this. And this is going to be a distance time graph. So in other words, I don't think I said this very clearly. In other words, this is a speed time graph of an object getting faster. What would that look like on a distance time graph, which is one y'all are familiar with? So in other words, I want you to turn this into something you're familiar with. Go ahead and I'll give you a couple minutes to think about it, and I want you to turn on your camera and show me what you got for an answer. Okay. Everybody drawing a distance time graph to represent that speed time graph? So what would a distance time graph look like? Okay, let's do this. Everybody show me your answer. What do you think it looks like? All right. Thank you, Jaylee. Very good, Jaylee. Everybody show me, okay. I can't see who that is. Very good. That's showing it to me. It looks like a classroom. Let me expand my screen here. Okay, Jaden, very good. All right, come on, guys, show me some answers. What do you think that distance time graph looks like with something speeding up? Come on, King, draw a graph. Okay, very good, Jalissa, thank you.
On a piece of paper?
On a piece of paper, yes. Shiloh, Shabby, show me your graph. Show me your graph. What would a distance time graph look like? that matches that speed time graph? Okay, good try. Zidane, Samantha, Diego, Kia, Jade. All right, very good, Diego. Huh? Nope, I don't see her. Jade, was it you or her that was absent Friday? I thought one of y'all came and one of y'all stayed home. Was that Thursday? All right, thank you, Jade. Okay, so Naima, do you have a graph to show me? Dion, Samantha, Kia, come on. This is all about practice. Practice makes perfect. All right, so here's what it should look like. Here's a distance time graph to match that speed time graph. It should look like this. Getting faster and faster and faster and faster. Okay? So notice I have an equal sign here. That means that they are the same or they are equal. So in other words, this graph, the speed time graph, is showing the exact same thing as this graph, the distance time graph. Okay? All right, very good. Thank you, King. Okay, but King, you're going to want to draw these very small because we got a lot to draw. Okay, number 8. Everybody go and draw number 8. First thing I'm going to do, I say the second graph. First thing I'm going to do is I'm going to look at it and say, oh, this is a speed time graph. Okay. Oops, actually, no, it's the same one as last one. This one. Okay, so first thing I'm going to do is I'm going to look at it and say, yeah, that is a speed time graph because right there it says speed. So what I want y'all to do is I want everybody to draw a distance time graph that shows the same thing. So what would a distance time graph look like to match that speed time graph? So I didn't see that. Show me your distance time graph. What would a distance time graph look like? All right, everybody trying the camera, show me your answer. Draw a distance time graph that matches that speed time graph. Okay. All right, Shiloh, Jade, Diego, Jalissa, Michael, Naima, Zidane, Dion, Samantha, Kia. Everybody show me your answer. This is all about practice. You don't practice, you don't get perfect. Okay, thank you, Jaden. All right. Thank you, Jade. Oh, very good, Jade. Okay, good, Jalissa. Okay, so let's talk about it. Jalissa, what can you tell me about this speed time graph? What is that object doing? Is it speeding up, slowing down, or staying at the same speed? I'm sorry, let me turn up my microphone. I can't hear anything. All right, one more time, Jalissa.
It's not moving.
Okay, so let's look at that like this. This is 0 miles per hour, 5 miles per hour, 10 miles per hour. So what do you think now?
It's moving at 10 miles per hour.
Okay, in other words, a constant speed, yes? Would you agree with that? It's a constant speed? Yeah, okay. Yeah, this is a speed time graph, and what this is showing is an object traveling at a constant speed. How do we draw that on a distance time graph? Like this, a straight line. That looks like it curves, but it's a straight line. It's supposed to be. So yes, that's what a distance time graph, the same one, would look like. It's a straight line. Okay. In other words, graph A is the same thing as graph. This speed time graph is showing the exact same thing. It's equal. That's why I circled equal to this. They're both traveling at the same speed. Okay. So for example, you know, if I put 20 here and I put 2 here, what's 20 divided by 2? 10. It's traveling at the same speed as A. Okay? All right. I guess we can do this one. Okay. Everybody draw this graph. The first thing I'm going to do is I'm going to look at my units. And what's my unit? Speed. All right? So my unit is speed. The question is, what is that graph showing? All right, Shadows, what do you think that graph is showing? Some speeding up, slowing down, or going the same speed? No, Shadow, without a graph, what is it showing? What's it doing? Speeding up, slowing down, or same speed? Okay, very good. Yes, it is slowing down. Okay, so what can we say about the speed here? We can say that it is slowing down or a decreasing speed. Okay, very good. So yes, this one is decreasing speed. So now what I want y'all to do is draw a graph of a distance time. Draw a distance time graph of an object decreasing speed. What would that look like on a distance time graph? And again, these are the distance time graphs are the one we've been working on, so y'all should be very familiar with these. Okay, turn on your cameras and show me your answers. Okay, looking for distance time graphs. So what would a distance time graph look like? All right, thank you. Come on, people out there. Sedon, Dion, Samantha, Kia. It's all about practice. All right, very good, Jaylee. All right. Thank you, Jade. Okay, so here's what it should look like. On a distance time graph, does this represent an object slowing down? Yes. Okay, so in other words, this speed time graph and this distance time graph show the same thing. It shows an object slowing down to a stop, or actually slowing down, not to a stop. And we'll actually look at that tomorrow. Okay, so we're actually a little bit ahead. I don't know what I missed. That's going to be it for the day. I'm actually going to go back over the warm-up because I need to make a recording. So if you want to stick around for that, you can. But save that notebook page for tomorrow because we're going to do some more distance or speed time graphs tomorrow. And we will also look at that moving man lab again. Oh, that's what I forgot. So one thing I forgot is missing work. If you are missing the, let me think of the name of it, the Simple Machine Lab, aka the Pickle Lab, I sent you a email on Friday, and I probably sent out 40 emails to students missing that lab. If you're missing that lab, you're a guaranteed failure because that lab is 40% of your grade, okay? So in that email, I sent you a link to a YouTube video. Just go watch the YouTube video and answer the questions on the lab and get it turned in. So following people, I have not got that lab back yet. Oh, how did I end up in third period? Let's see here. Here's eighth period. Okay, so following people, let me see. You need to turn that lab in. Actually, what I need you to do is I need you to go check your email, and you will find an email that has the direct link to the video. You don't have to do the lab. You watch the video of me doing the lab, and you just answer the questions and turn it in. So that is going to be, let me see, got to find it first. Here it is. So Shiloh, you finally turned yours in. Very good. Diego, why don't you go work on that right now, okay? Go to your email and look at your simple machine. And looks like a few of y'all have turned it in since Friday. All right, pretty good. Okay, again, I'm going to go back over the bell ringer for those who are absent. I usually do this early in the day, and I forgot. Yes. Yes, I will see y'all tomorrow. Have a nice day. Hold on to those notes because we're going to expand on those notes tomorrow. So for the bell ringer, what we talked about was diagram C. Diagram C is when he first jumps out of the airplane. The force of air friction is less than the force of gravity. So it is an unbalanced force. And what is happening is his speed is increasing. Why is his speed increasing? Well, because the net force looks like 133 newtons going down. The definition of unbalanced force is a change in motion. So he is going to change his motion. He's going to get faster going downwards. Where with diagram D, you'll notice that the force of gravity is equal to the force of friction. So 833 newtons minus 833 newtons give me 0 newtons, which is a balanced force. As a result, he's going to travel at a constant speed. That constant speed with the average human skydiving is about 120 miles per hour. And what happens, it's called terminal velocity, is that the force of friction is equal to the force of gravity. And what happens, you don't stop falling, you keep falling, but you fall at a constant speed of about 120. That's it for today. Goodbye.